In this video, I'm going to talk about how to review practice questions. Practice questions are one of your most important resources, but how much benefit you get out of them depends on how you're using them. In my opinion, this all comes down to how you review them. If you have a good review process that challenges you and keeps you actively engaged, then you should see a lot of progress. And in this video, I'm going to go over the review process that I share with everybody that I tutor. The entire process that I'll go over takes place after you've done your questions under normal timed testing conditions. So you can take as much time as you need to complete everything that we're going to talk about. The majority of MCAT questions are passage-based, so most of this review process is going to be focused on rereading and analyzing a passage. At first, going as in-depth as we were about to do is going to take a lot of time and effort, but as you do it more, your skills and your background knowledge will improve, which will make it go a lot more quickly and smoothly. I'm going to use this passage as an example to work through, and we'll start right at the top. The first and the most important thing that I do is I break up what I'm reading into smaller chunks, because it's really hard to understand a complex paragraph when you read it all at once, but one small piece at a time is very manageable. When I look at this paragraph, the first chunk that I want to process is the first sentence. For each piece that I process, I explain what it means, and I make sure to go more in depth and not just regurgitate what's already written. This part often requires you to use your background knowledge, so as you get a better mastery of the content, you'll be able to give better explanations. Now I'll show how I would explain and elaborate more on this first sentence. There's a lot to expand on here using our background knowledge. We know that exercise requires ATP, and we know that the mitochondria is heavily involved in making ATP. So it makes sense that exercise would improve the function of the mitochondria. We aren't told how it does that, but that's exactly the type of thing that you want to be thinking about on your own. So try to come up with some possibilities. Some ideas that I can come up with based on my own background knowledge is that maybe it improves the transport of pyruvate into the mitochondrial matrix. It might increase the activity of the Krebs cycle, the electron transport chain, ATP synthase, or fatty acid oxidation, all of which would increase the availability and production of ATP. And I'm going to stop here because I think we've covered a lot of the good high yield content, but based on your own background knowledge, you might be able to expand more on this and talk about more biochemical pathways that could explain how the mitochondria is improving its function as a result of exercise. Now that I've elaborated and explained what that piece means, I want to bundle it all together into one easy to understand sentence. For this one, my sentence is, exercise increases the rate of fatty acid oxidation and improves mitochondrial function in other ways to improve its ability to make ATP. That's the only piece that I'm going to break down as an example in this video, but I'll do future videos where I break down the entire passage. But the idea is that you just apply that to the rest of the passage, and then just make sure that for each new piece you analyze, you're also connecting that back to the previous things in the passage that you've already gone over. And then once you do the whole passage like that, create a summary that ties it all together. At some point during this process, you might find some pieces too difficult to analyze, even after you've broken them down into smaller chunks. Always try to figure these things out using what you already know and context from the passage, but if you think you're missing crucial background information, go ahead and take the time to look that up. See if it helps you figure out that piece, but if it doesn't, you might need to build up your passage skills and your content knowledge a little bit more, and that's going to happen gradually as you practice and study more. That concludes the general approach to rereading a passage. Now let's look at how to apply that approach to passages that have experiments, because there's a few extra things that might help you with those. The first thing that can help you is to recognize that experimental-based passages generally have the same template. First, a question or problem is introduced, and then they describe an experiment that's supposed to provide answers to that question or problem. That's followed by results, and then sometimes there will be some discussion or conclusion. When you read the first part about the question or the problem, approach it using the exact same methods that we've already been discussing. When you read the second part about the experimental design, put extra emphasis on visualizing the experiment, and it can even be good practice to draw this out. Then think about how that experimental design could generate the results that could answer the question proposed earlier in the passage. You'll usually have to use your knowledge about lab techniques, so as you become more comfortable with that content, you'll become a lot better at this process. If you find yourself analyzing an experiment and you feel like you're missing crucial information, take the time to look it up and see if it helps you understand the experiment. Once you feel like you understand the experiment, look at the results. Pay extra attention to how the results are set up, so look at things like the x-axis, the y-axis, scales, units, titles, or anything else that helps you understand the presentation of the results before looking at the actual data. Based on your understanding of the experimental design and on how the results are being presented, make a prediction about what the data is actually going to be. Then look at the data and see how it compares to your prediction. And if the passage has a results section, see how their conclusions compare to yours. Now let's apply all of that to the experiment and the results in this passage. I'm going to skip over the part that introduces the question because we've already gone over the techniques on how to break down something like that. And we'll start by breaking down the experimental design. So the mice in this experiment are separated into two different groups. One group is given a placebo and the other group is given this drug. And this drug mimics exercise and increases fatty acid oxidation, which was mentioned in a part of the passage that we did not go over. Both groups are fed the same high-fat diet, and then after 4 weeks, they measured the amount of ACC mRNA and the rate of fatty acid oxidation. Using some background knowledge, we know that ACC is acetyl coenzyme A carboxylase, and that's the rate-limiting enzyme in fatty acid synthesis. Fatty acid oxidation is something we've already talked about, and that's the breakdown of fatty acids to help make ATP. Now we have a solid understanding of the experimental design, and we can look at how the results are presented. We have two graphs here, and the titles for each of them obviously show what's being measured. The x-axis for both of them are just the two groups of mice. The y-axis for this one shows us the amount of ACC mRNA expressed as a percent of the control group. So our control group is at 100%, and then the other data shows us how much mRNA there is relative to that amount. The y-axis for the other one shows us the fold change. And what fold change is a ratio between two measurements. Now that we understand how the results are going to be presented, we can make our prediction. If the drug works and it mimics exercise, then we should expect higher rates of fatty acid oxidation in the mice who were given the drug, because exercise induces fatty acid oxidation, and we were directly told that the drug increases the rates of fatty acid oxidation. And we should also expect the amount of ACC mRNA to be decreased in the experimental group. We can say that because from our content knowledge, we know that fatty acid synthesis is downregulated anytime fatty acid oxidation is upregulated. And since ACC is involved in fatty acid synthesis, it should be downregulated. Now we can look at the actual results and compare it to our prediction. If they match, that means we probably already understand the mechanism that generated these results. But if it doesn't match, try to come up with some mechanism to explain those unexpected results. For this one, the results do match, so we're done breaking down this experiment. This example was pretty easy, but you can apply this same approach to more difficult passages, and as you do this more and get better at this process, you'll be able to break down even the most challenging passages. Everything we've talked about so far has been about rereading and analyzing the passage independent of the questions. And in my opinion, it's best to have a great understanding of the passage before looking at the questions, but now we're going to look at how to break down and analyze questions. When you review and break down questions, I strongly suggest that you don't have the answers revealed. If you already know what the correct answer is, you're more likely to find a way to justify it and convince yourself that you understand it, whether or not you truly do. So without the answers revealed, reread the question and break it down using the same approach that we've used for the rest of the passage. And let's apply that to this question here. From our content knowledge, we know that CPT1 is the enzyme that transports fatty acids into the mitochondria to undergo fatty acid oxidation. And we already know that ACC is involved in fatty acid synthesis, so this question is basically telling us that we have a new drug that's even better at increasing fatty acid oxidation and decreasing fatty acid synthesis. Once you understand the question, use your content knowledge and your passage understanding to come up with one or even multiple answers. Challenge yourself to recall and explain more than just what's needed to answer the question, so you can use it as a sort of pop quiz over the entire topic that it's related to. It's a lot to talk about, but you'll find that it makes the answer very obvious, and if you consistently do this for all of the problems that you review, you'll develop a very strong ability to recall and apply MCAT content. For example, for this question, you would want to try to recall all that you can about fatty acid oxidation and fatty acid synthesis. This would include things like naming the enzymes, the intermediates, the rate-limiting step, the location in the cell that these take place, and you could even talk about how these processes relate to other biochemical pathways. I'm not going to get into all of that in this video because of how much time it would add, but I will do that in future videos where I'm breaking down passages. Once you finish that, go through each answer option and explain why it's either correct or incorrect. And after all we've already done, it should be pretty easy to do. Now let's finish by going through our example here. For option A, we can say that ACC does create malonyl coenzyme A, so if there was more ACC, there would be more malonyl coenzyme A. However, we have nothing to suggest that there would be an upregulation of ACC. In fact, we're specifically told that it's downregulated, so we can get rid of option A. For option B, remember that CPT transports fatty acids into the mitochondria. We were directly told by the question that this new drug enhances the activity of CPT, which directly contradicts option B, so we can eliminate this answer option. For option C, based on our background knowledge, we know that ketones are made from acetyl coenzyme A, and fatty acid oxidation makes a lot of acetyl coenzyme A, so it makes sense that with more fatty acid oxidation, we would have more ketones. So this drug resulting in more ketone body production does make sense, and option C is probably the right answer. Let's just make sure that we can eliminate option D before concluding that. Acetyl coenzyme A feeds into the TCA cycle, so with higher rates of fatty acid oxidation, we'll expect more acetyl coenzyme A and higher rates of the TCA cycle and of ATP production. By the time you finish going through each answer option, you should be pretty certain whether or not you got the answer correct. And now you can reveal the answer and either confirm that you got it right for the right reasons, or figure out what you were missing that prevented you from being able to solve it. If you weren't able to solve something because you were missing the necessary content knowledge, then record that piece of information somewhere like a spreadsheet so that you can revisit it later and get it memorized. If you use the scaffold approach that I talked about in my video about how to review content, then you can put this information in the appropriate spots in your scaffolds. Repeat this process for every question, and then you're finished with your review. Like I said earlier, this process is pretty time consuming, but getting the most out of your MCAT questions is all about the quality of your review, not about the quantity of the questions that you do. And the more that you practice this, the more confident you'll become, and the more quickly you'll be able to do this. I'll post more passage review videos in the future, and I encourage you to watch those, so subscribe and turn on notifications if you want to be notified when those come out.